Fine, guys, let's start. So in previous session, fine. So we have seen these concepts, right? So we have seen the ML DLC, okay? Machine learning daily life cycle. So it's at a high level, these are the steps involved, guys. So today we are going to take a toy data set, okay? That means a simple data set, and we'll try to see end-to-end implementation. Okay, so right from the data gathering, so till the model building, and after that how to pickle the model and save the model. Okay, once this is done, you can deploy this into some app or web app, or you can use it as an final product. Fine, so let's try to do that today. Okay, so it will be, we in other words, we are going to see each of these steps which we have mentioned over here in detail. Fine, so let's start, guys. Yeah. So before starting, so this is our data set. Okay. So we have three columns. Fine. So one is CGPA, one is IQ, and one is a placement. Fine. So CGPA is more or less his grade, and what is his IQ, and what is his placement. So first, initially, our task would be to understand the data set. Since this is a toy data set, it is very easy to understand. Okay, we can see that placement is a target variable. Agree? Fine. So, and these two are our input variables. Fine. So before starting, guys, whatever we are going to discuss today, fine. So this end to end, this will act as a backbone for you guys, because in future, when you work in real life projects, so the steps will be more or less same. Fine. So what are the steps which we are going to discuss over here, right? The overall structure will be mostly 80 to 90% will be exactly the same. Only the data set will be different. Obviously, you'll be working on a large data set, complex data set, or a very real-time data set. Okay, very I would say uneven data set where you need to do more pre-processing, more cleaning, more EDA might be involved. Okay, but at a high level, or at a bird's view level, fine, so the steps will be more or less same. Okay, so and this is the approach which we are going to follow for almost all the algorithms we are going to discuss. As I said, around like 10 algorithms, right? So for every algorithm, the steps will be same. Okay, how we are going to import the data, how you are going to process the data, how you are going to plot the data, how you are going to split the data, right? So we are going to discuss each and every step today. Fine. So understand the structure. Fine. Understand what is coming after what. Fine. So that this will act as a reference, okay, going forward. And I would say from practical experience, this is same we are going to implement even in your real life project also. Fine. Only the models will be different. Fine. So as I said, this will act as a backbone. Fine. So but only you can do some enhancement. Fine. You will explore with more models, you will explore with more accuracy metrics, you will explore with more plottings. Okay, but more or less the steps will be same. Okay, so understanding this will give you a definitely very good idea about end-to-end process of any ML project. Okay, fine, guys, let's start. So that's why my suggestion is, make sure you understand every word and every code and every line in today's class. Okay, wherever you're not understanding, right, so just stop me and ask me. Okay, so that it will be helpful for you and also others. And if you understand this end to end, right, so I would say it will be very easy going forward. Okay, so make sure you understand it well. So now, as I said, first step is, as you can see, we are importing few libraries. Okay, so NumPy, Pandas, this we are very familiar with. Fine. And after that, the first step would be, obviously, we need data. Without data, we cannot do anything. So we are doing what? We are importing the data, placement.csv. Fine. So over here, the data is already available for us. Okay, so I'm just doing read CSV, but in real life, it might not be that easily available. You might need to coordinate with different teams. Okay, and or sometimes you might need to extract it from some website, or sometimes you might need to pull it from some tables, join, etc., etc. Okay, so that comes under, let's say, data engineering stuff. Okay, in some projects, in some companies, you will have a separate person as a data engineer who will be providing you with the data, or in some companies you will be the person who will be extracting that. Okay, so but now, assuming that you got the data, Fine. So now this is in your CSV. Most 90% of the time you will be working on CSV formats. Okay. So these are my data. First thing is you should have an basic understanding of the data, at least from the ML point of view. Because what do I mean by ML point of view is, if it is a medical data, fine. If there are some terms like some disease related terms, I will not be able to understand what are those. But at least from ML point of view, I'll understand whether it is a target variable, whether it is a categorical variable, whether it is a continuous variable, okay, whether it is some input variable or output variable. Okay, these type of technical knowledge you should be able to understand. Okay, so here I can clearly see that I'm having two inputs, CGPA, IQ, placement is my output variable. Fine, and this output variable is, what is the nature of these guys? Is this continuous or is this categorical?
It's a categorical.
Cool, this is categorical nature, because you can see either 1 or 0. Okay, either 1 or 0. There are no in between values. Fine, there are two categories. So obviously this is categorical in nature. That's fine. And after that, we are having two input variables, CGPA, IQ. Fine. So you have two features. Okay, and obviously there will be always one target variable. Okay, so data set, we got some basic idea. Okay, any doubts in the basic data set, guys? Because I'll go a bit slow. Okay, so that we'll understand each and every step well. Okay, any doubts in the data set? Not this data set. See, when I'm discussing this, don't confine to only this. Okay, you can ask any general doubts regarding the data set concept. Okay, are we good till this point?
Yes, Santosh.
Okay, so after that, df.head, obviously we know it will give you the top 5 rows. Okay, so these are top 5 rows. Okay, it will just give you the top 5 rows. Okay, that does not mean this is our data set. Okay, the whole data set is obviously how many rows, guys? Okay, so for that we can do df dot shape. Fine, 100 rows, 3 columns. Okay, so when you do head, it is giving you 5. When you do tail, it will give you the last 5. Okay, that we are aware. And df dot info will give you some further information, like it is saying 100 entries, net starting ranging from 0 to 99. Total there are 4 columns. 4 in the sense it's also considering this hash, I would say this index. Okay, and column name. Okay, and this is non-null content, and what is the data type. Okay, and data type CGPA float, IQ float. Okay, and placement is int. Okay, fine. So after that, we are having shape. Okay, fine. So now what we are doing, so here we don't want this. Okay, we don't want this column because this is just an index. Fine. So what we are doing, see, we have see, as I said, what all we have studied either in pandas or numpy, matplotlib, statistics, right? We'll be using this. Okay, not all, at least as per the requirement. So here what we're doing, we are just slicing the data set. What we're doing now, this is a table df. Now what is table, what is df? Df is our data set, and this is just a table in the sense, what, it's a pandas data frame, simple pandas data frame. And now since it is a pandas data frame, obviously we have the facility to use all the pandas functions we have learned. So what we are doing, so here if you see, I'm saying df dot iloc in the sense you're selecting what you're selecting. See, I'm just doing semicolon, I'm not specifying anything. That means select all rows. Okay, but coming to columns, I don't want to select all columns. I just want from 1 to end. That means start from 1. That means what? I am ignoring the 0th column. Okay, what is 0th column? This column. Oh, sorry, this column, index column. Okay, I don't want that. So start from 1 and take everything. Okay, that means start from CGPA and take all these 3. I am ignoring this. Okay, because that is just index. I don't want that. Okay, so that is how I'm using the same name df. Okay, you can use any other different name also, but usually we use the same name because if you use it every time, if you start using different name, unnecessarily it will occupy more storage, right? And this df1 df2, okay, we are not going to, ultimately we are going to use only one. Okay, so why to create a new variable and new space storage every time? Okay, that's why we always overlap with the same name. But if you think that if you want a separate variable, and if you want to store it in separate storage, that then you can go with the different name like df1, df2. Okay, but here I don't want df. Okay, I want the latest df. Okay, so that's why I'm using the same name. Okay, so now my df is this. When I do df.head, earlier my df.head is like 0 1 2 3 4, but now it is just cg, just these three columns. Okay, it has removed this index. After that, this is basic slicing which we have done. So once you have done this, next these will be the more or less the steps which we are going to follow, guys. Okay, so if you see, once you have the data set, first thing is you are going to pre-process. Okay, that means what? Pre-process in the sense you are going to verify whether the data is clean or not. Okay, whether it is having any missing values. Okay, fine, and whether there are any unwanted columns, etc. And EDA, exploited data analysis, we are going to see, and we will be doing the feature selection. Okay, and we are going to extract input and output columns, scale the columns, train test. Okay, fine. So this is the structure which we are going to see. Now, what type of EDA you are going to use, how you are going to feature selection, fine. So these are going to change from data set to data set. Okay, so now this EDA is a very important concept. Okay, because this is always going to be dataset specific concept. Fine. So the all the EDA which you are going to use on this dataset will be very much different from some other dataset. Okay, because the nature is changing, right? Because what is EDA? You are trying to explore something. Okay, you're trying to understand something. I mean, the dataset is changing. Obviously, what you need to understand will also change. Fine. So that we are going to see. Okay, so but just make a note mentally that what are the steps which are going to involve. Fine. So post that what we are going to do, first of all, our aim is what, guys? Our aim is, did you understand the aim? Simply speaking, my aim is I want to predict placement given CGP and IQ. Is it clear, guys? What is my problem statement over here? What I'm trying to do, solve what algorithm, what all we are going to use, that comes later. Forget about that. Fundamentally, what is my goal today? My goal is, if given CGPA and IQ, I should predict placement, whether he got placed or not. Okay, looks like 0 means he got not placed and 1 is he got placed. Getting, guys?
Yes, Santosh.
Is a problem statement clear to everyone?
Yes, sir. Clear.
Okay, fine. And also you can also see here, see wherever you are having 1, see here 1. Okay, that means you got placed. And okay, CGPA and IQ is bit high. But here let's say 0, that means 5, and IQ is very less, so he got rejected. Here IQ is great, but his CGPA grade is less, that's why he got rejected. Okay, so more or less those combinations. Okay, there's not like clearly we can predict everything manually. Okay, but you can see if the grade and IQ both are high, he is getting placed. Okay, fine. But now this is a data. Okay, what is this data? This data they have collected manually. Okay, 100 people they have manually measured these details. Okay, for 100 students or employees. Okay, they have collected these grades and they have done some IQ test and they have collected the scores, and also they also collected their corresponding placement details, whether he got placed or not. Okay, those data they are giving us. Okay, this is 500 data. Now my goal is, and also I would say the importance, the helpfulness of machine learning is, with this 100 rows, if you train a model, okay, now it can predict for any number of rows. Okay, so it just needs some training data to understand the relationships. Once it is trained, now you can give any number of inputs. That means you can give any number of combinations. It is going to predict its corresponding output. Okay, so that's the importance of ML. Now we are going to see this. Now, going back, first of all, if you want to predict this particular value, okay, predict this particular value using these two, okay, there are different algorithms. Okay, I'm not going to in depth regarding the algorithm, guys, because that is not the scope of this video. Okay, but I will tell you few things. Okay, what we need to do over here. If you see, if you remember in our matplotlib session, we have discussed the scatter plot. Okay, and there we also discussed something called as this. Okay, we are plotting these two, but I want to color code. I want to color code. C is for what? Color code, if you remember. I want to color code with this particular column. Getting? So out of these three columns, I want to plot the data point with these 2 points, but color coding will come from this particular column. You remember this particular step which we discussed?
Yeah, yes, Santosh.
Fine. So now if you see, I'm plotting CGPA and IQ. That means what? It will take this value 6.8, 123. It will plot it. Next 5.9, 106. Plot it, because to plot any point on a 2D space, you need how many points? 2 points. So this is 1 point, this is 1 point. Okay, using these two columns, you can plot the data sets. Okay, data points. Okay, all are plotted. After that, I am using this column. What is this column? Placement column. To color code the values. So now I am able to use this C equal to D of the placement, and it is color coded. How it's color coded? Wherever it is having 1, it is given one color, and wherever it is giving 0, it is given another color. Okay, whether blue is 1 or yellow is 1, I am also not sure. Okay, to do that, you can also add something called as what do you add, guys? Forgot that. In Matplotlib, we add
Is that label?
label, right? It's called label.
Yeah.
Fine, labels, and what do you say? X label, Y label, and there is something called as title. And what was that? It just skipped my mind. It starts with F, guys. It just skipped my mind. Anyways, okay. So you can, I hope you can, know how to just give the ledger. Okay, yeah, I got it. It's got ledger. Okay, so where it shows which color belongs to which data point. Okay, fine. So with this is giving us a very important information, guys. So if you see over here, there is a clear bifurcation between two types of data points. Getting? All, let's say, for example, this blue equal to 1. Okay, or simply we can also guess, guys, because see, wherever you are having what is this? This is IGPA, guys. This is IGPA, and this is what? This is score. This is IQ. Okay, fine. So we want high IGPA and sorry, high score and high IGPA. So let's say blue equal to 0. Okay, because they're having low scores, and yellow equal to 1. Okay, what is 1? 1 is placed. Okay, fine. So now the point here is there is a clear, almost clear, there are few overlaps over here, but almost there is a clear bifurcation between. That means what? If I draw a line over here, okay, I can almost, not 100%, but almost I can say there is a clear division between selected or placed people or not placed people. Getting what I'm trying to say over here? Because ultimately, what is our goal, guys? My goal is to predict. Okay, my goal is to predict. Fine, whether this guy got placed or this guy not got placed. Okay, so to do that, as a from machine learning point of view, okay, first of all, I should be able to see whether, okay, whether these two are able to get divided from each other or not. Okay, what do I mean? Because, for example, if you see this is we are going to do with a specific algorithm, guys. Okay, there are different types of algorithms, okay, which can which behave differently. Okay, but since we are using the toy data set, okay, as of now we are using a specific algorithm. Okay, we are using a specific algorithm called as logistic regression. Okay, but as of now you don't need to worry what is logistic regression, etc. Okay, but just with common sense, let's try to understand. If given data set and if my goal is to predict whether it is 1 or 0, okay, I want to predict whether it is 1 or whether it is 0, guys. Okay, so obviously there should be some differentiation between these two values, right? If at all, see, if at all blue and yellow are completely overlapping with each other, that means blue is over here and yellow is completely over here, it is very difficult for me find to predict for a given input values. Agree? But now in this case, I can say, as an example, I can say, if the score is, what is this? This is CGPA, right? CGPA. Okay. If the CGPA is greater than 5 or 5.5, okay, 5.5, I can say he's getting placed. If it is less than 5.5, it is not placed. Something like that. Are you guys able to understand?
Yes, Santosh.
We have
So,
seen.
but it doesn't matter about IQ level.
Correct. Okay, as an example.
Yeah.
We have seen a similar example in the iris dataset also. You remember? In the iris dataset also, we are able to predict with one particular value called as sepal, I think petal width. Okay, just
Yeah,
by petal width, we are able to segregate one type of flower, setosa. Okay.
yes, Santosh.
So if you remember, if the value is less than, or let's say, or if the value is less than 2, okay, sorry, if the value is less than 2, as an example, if the petal length is less than 2, it was directly becoming setosa. Okay, but if it is greater than 2, it could be either versicolor or virginica. I'm not sure. Okay, but if it less than 2, we got one particular flower. Okay, what is our ultimate goal? To reach any one classification category. Here, what are my categories? There are two categories, either 0 or 1. Okay, my ultimate goal is, if given any input, okay, if I say, hey, CGPA is, let's say, some 9.6 and my IQ is some 134, I should be able to directly tell him whether it is my output is either 0 or 1. My prediction is either 0 or 1. Okay, I cannot say it could be 0, it could be 1. That is not the point of ML. Okay, I should be able to say with maximum probability that it is 0 or it is 1. To do that, fine, we are trying to take the help of this plotting and understand, okay, whether these two are segregated or not. Okay, and you can see, yes, there is some clear segregation. If the value is some greater than 5 or 5.5, you can say this is belonging to this, and if it is not, if it is belonging to this. Okay, but obviously there is some overlapping over here. I can understand there is some overlapping over here that we are going to see. Okay, but with plotting you can understand whether the data points can be separated or not. Okay, whether the data points can be separated or not, and we are separating on based upon what? Output category, and that is what we need. Okay, so ultimately we want to separate all these categories, guys. Okay, we want to separate all these categories so that if given an input, we can directly say this is 0 category, this is 1 category, this is 2 category. There should not be any dilemma. This could be 0 or 1. That means it is not, we are not predicting. Prediction is directly we are saying, hey, this is 0. Or if there is some other category, hey, this is category 2. Okay, that is called as classification. We are classifying all this into 0 category. We are classifying all this into 1 category. We are classifying all this 2 category. That means we are doing some classification. Are you getting this? Any doubts? Any concerns?
Fine, Santosh.
Others following?
But in this, we cannot follow the logistic regression, no, sir.
What? Sorry?
Logistic regression problem is not suitable for this, no, sir.
Why?
We draw a line, some of the Unplaced students also come under the placed students, sir.
Correct. But see, more 99% of the values we are able to reach, right? We will not get 100% every time. See, almost see if you consider, if you draw a line over here, almost over here, you're able to get almost, see, if you see the blue points, just 3 or 4 points are overlapping over here. And if you see the yellow points, only 2 or 3 points are overlapping here. But 95% of the time it is working. Agree? Hello?
Got it, sir. Not 100% accurate, but we can follow up to 95.
Yes. But this is a basic example, Sirisha, just to give you the overall structure. But if you want 100%, you can go for further algorithms, like you can go for decision trees, or you can go for some boosting algorithms, which will give you better accuracy also. Okay. But as I said, today's video is not about the models. Okay. Today's video is about the end-to-end structure. Okay. Fine. So, okay, getting?
Yes, sir.
Okay, so this is regarding the basic plotting, guys. Okay, after that, you need to divide the data set into what? Input and output. Okay, so over here, if you see, what is my input? This is my overall data set. Okay, and what are the inputs, guys, over here? My inputs are these two. Okay, and my output is placements. Agree? And that you need to divide. So over here, x and y. Okay, so x will be the input and y will be my output. Okay, now how I'm going to get x is just div to dialog, take all rows. Every time we'll take every row. Okay, as you can see here. But the column, if you see what column I'm taking 0 to 2. That means what columns it will take? 0, 1. Okay, only 2 columns it will take. Agree? And for y, what we are doing, we are taking the -1. That means last column I'm taking. Okay, so in other words, so if I just show you over here. Okay, so now over here 0, 2, that means 0, 0 and 1. Okay, that means these two columns became my x, and -1, that means this placement became my y. Okay, so when you now print x, you got these two. Okay, and when you print y, okay, let me print y also. You will get only this name placement. Okay, this column. Okay, so that's how you have created. You have mentioned what are your inputs and what are your outputs. Okay, as I said, you can have multiple inputs. Okay, so here you are having how many inputs? 2 inputs you are having. Okay, this you can say as x1, and this is my x2. Okay, x1 and x2. Fine. So, but you are having one output. Are we good till this point? Clear how you can create inputs and outputs x and y?
Yes.
Okay, cool. So after that, what we are going to do over here is you are going to divide it into training data and test data. Okay, so this is a very, very important step, guys. Now let's try to understand this. Okay, let me just create. Okay, so now next step, what we are doing is what we have done. If you see over here, see what we have done. We have x, okay, we have y. Okay, now inside this x, we are having x1, x2, 2 inputs. Okay, that's fine. And y is only one output. Okay, till here, this is point. Overall, 100 rows you are having. Okay, this is fine. Now, as we know in our previous class, so what we are doing, we are training the model, one step, and second thing is you need to evaluate. That means you should also test the model. Okay, so any machine learning project will obviously involve, one is training, okay, one is testing, guys. Okay, this is very, very important. Focus. Okay, now the point over here is, here total how many rows we have, guys? We have 100 rows. Okay, Now we have 100 rows. We have input X, we have output Y. That means we have features X1, X2, and my target variable is Y. Okay. And my problem statement is clear. Okay. And my model is also clear. Okay. For example, as of now, I'm using logistic regression. Okay. So if you are not comfortable with logistic regression, okay, you can just assume it as some ML model. Okay. So I have my some ML model also I have. Now, what is the point over here? I am going to pass this data. Okay. I'm going to pass X to this model. That means X. Okay. Forget about X1, X2. You can have any X1, X2, but at high level, it is just X. Okay. This it's called just input. And you are going to pass Y also to this ML model. Fine. Now, what model you are going to use, based upon that, it will try to understand the logic between X and Y. Agree? If you use logistic regression, it will have one approach. If you use some other decision trees, it will have some other approach. Okay. We are going to discuss those when we come to those classes. Okay. But as of now, we are using some ML model. Okay. Based upon the max inside it, based on the algorithm inside it, logics inside it, it will try to understand what is the relationship between X and Y. Okay. That is done. Okay. So we got the model. Now, since we got the model, that is training is done. This phase is called training. That is done. But how can we trust this ML model? Only by doing some testing. How will it is performing? Fine. So to do that, we need to do what? First is training. Okay. First is training. I'm passing X and Y. Okay. Training is done. Next is what? Testing. Okay. How will it is performing? Now to test this ML model, I don't have any data, because all my 100 rows I used over here. Okay, all my 100 rows I already used up over here. Now I don't have any rows left to do the testing. Are you understanding the problem?
Yes, Santosh.
Okay, but now if you say, hey Santosh, we can use the same 100 rows for testing also, we can do that. Okay, but the problem over here is we will do that. Okay, but it is having an advantage and it's also having a disadvantage, because while training we use this 100 rows. That means what? The model has already seen all the data, all the 100 rows it has already seen, and it has understood the logic between those. Okay, and if you are using the same data set for the testing also, that doesn't make any sense, right? Because testing should always be on something new. Only then you will understand the caliber of this model. Fine. So as an example, I think I've already given this example, but let me give it again. So as I said that if you are studying for intermediate, fine. So in IP, what happens is whatever the questions you study, almost you will be asking the same questions in your exam. Fine. So like in each chapter, there will be some important questions. Okay. And if you prepare that, mostly you will pass. Fine. So, but that's not the actual test. What happens in this? What do you say? This IITs or in IIEEE exams. Fine. So there, no matter how much you prepare, you will not see a question which you already prepared. I mean, the questions will never be same. Fine. Every time in every exam, you will be asked a new question. Fine. So during training phase, that means while you are preparing, you got prepared on specific set of data. Okay, concept is same, but the questions will be different. While writing the exam, you are asked a completely different questions. Okay, those questions you are never seen while you are training phase. Agree? And in this scenario, if you are able to perform well, obviously you are a merit person. Trying to understand? But let's say you have prepared for 10 questions and exactly 10 questions you are asked in your exam, and you obviously you will solve them because you've already seen them and you got 100%. Does that mean you are a perfectly fit person? Getting the difference, guys?
Can you please repeat once, Santosh?
Okay, see guys, what I'm saying over here is, let's say while preparation, okay, let's say tomorrow is your exam. Okay, tomorrow is your exam, and today you have prepared 10 questions for 10 questions. Okay, in exam, You got exactly these 10 questions. You solve them. You got 100% accuracy. Okay, this is scenario 1. In scenario 2, let's say this is your IPE, intermediate exams. Okay, whatever the questions you study, you will get the same questions. Okay, you can by heart also. Okay, you can by heart also without understanding the actual meaning of the questions. Okay, or the logics, you can just by heart and you can write it, let's say, and you are able to score decent score. Okay, because the same questions are getting repeat. That means what I'm trying to say over here, I'm trying to say in training phase, that means in training phase, whatever the data you got trained, you got prepared, while testing, that means while writing exam, you are asked the same questions, so obviously you will perform well. Agree till this point?
Yes, yes.
But now let's say in scenario 2, you're appearing for IIT exam. You have studied, okay, you have studied the concepts. Okay, let's say even if you solve 100 questions, while writing exam, you will be asked completely different questions. Okay, so you will never see a question which you already prepared. Every time the question will be different, but the concept will be same. Okay, but the questions which you see, okay, the 10 questions which you're going to solve will be very new questions. Okay, that means what? During the training phase, that means during your preparation, whatever the data which you got exposed, okay, that questions you are not going to see during the testing phase. Okay, this will be different. That means while training data is different for you, and that means while whatever the data which you got prepared, okay, that is one thing. Why the testing data is different. Concepts are same, subject is same, okay, but the questions which you are getting, which you are solving, okay, will be different from the questions which you are appearing in the exam. Okay, now in this scenario, because you are testing, while testing, you are asked completely different questions. In this scenario, if at all you are able to perform well, okay, that means you really have some stuff, because you are solving something which you have never seen before. Obviously that involves your creativity, that involves your preparation. Getting, but here you are already seeing these 10 questions. Okay, so I cannot definitely say whether you are actually solving those, or whether luckily you got the, since you got the same questions, whether you are by hearting them or luckily you are remembering and writing. I cannot guarantee. Okay, because the same data you are getting over here, but over here you are getting, you are solving completely new questions, so obviously you have some stuff in you. Getting, did you understand the difference between these two scenarios, guys?
Yes, Santosh.
Okay, now same thing we let's try to apply over here. Okay, over here, if at all I have 100 rows, okay, if at all I use the complete 100 rows during the training phase, okay, and if I use the same 100 rows during the testing phase also, if the model is performing well, I will not be very sure whether the model is actually understanding the relationship between my input and output, or it is just remembering some logic, or okay, and it is just giving me the output. I cannot be sure, because I'm using the same data for training, and again I'm using the same data for testing also. Getting?
Yes.
Really?
Yes.
Getting? If I use the same 100 rows during training to train the data, and for testing the data also, if I use the same 100 rows, because it has already seen all these 100 rows during this training phase, right? There is chance that it can just remember by some sort, and it can give me the answers. Okay, it can just remember, hey, if this is the, see guys, I'll tell you what is the point of this project which we're doing now. It is, the point is not to work for these values, the point is not to work for these values, the point is to just understand the relationship between this input and output, so that after this, if I give you any random values, like in the place of CGP, I will give some 7.43, and in IQ, if I give some 154, it should be able to give me the output, either it is 1 or 0. Getting? My goal is not to work for this particular data set. My goal is to just understand the logic from this data set, so that it can work for any other data set, any other input values. Is it clear? This is extremely important point. So the goal of any training any ML model is to not work for that particular data set, because if I want to work only for this data set, why I should have a model? For just 100 rows, I can just manually Okay, remember and write down the values. Getting? My goal is just to make the model understand if these are the values, if CGPA is increasing and if the IQ is decreasing, how the placement is increasing, or how the placement is changing, whether it is changing from 1 to 0 or 0 to 1. That relationship I want to capture. Once a model understands that, once a model understands that, after that, if you give you any random values, any random CGPA or IQ, the model should be able to predict based upon its training. That is my goal. Getting?
Yes, Santosh.
Others, are you guys following? Like, if
Yes,
you
sir.
already know these concepts, or like, are you able to understand now in better way?
I understand, sir, clearly.
Okay, so now that is the reason. Now the problem over here is, try to understand, guys. Now the problem over here is, if I use, okay, if I use all these 100 rows, okay, if I use, let's say, all these 100 rows while training, I'm using, okay, the ML model. Oh, fine, it got trained. Now while testing also, if I use the just 100 rows, same 100 rows, and if the model is giving best accuracy, super, let's say some 95 accuracy it is giving, I cannot be very sure whether the model is actually understanding the logic or it is just remembering. That means what? It is also possible that model, because these are just 100 rows, model can blindly remember. If it is 6.8 and 123, give 1. If it is 5 and 63, give 0. If it is 4 and 100, give 0. It can remember that. It can do it that way also. I'm not sure what is happening inside. Getting, guys?
Yes, sir.
Getting, right? So it should not, this should not happen. Okay, it should not remember. It should understand. Fine. So that's why if I use the same 100 rows for during training and again the same 100 rows during testing, and if I'm getting good accuracy over here, I'll be confused because, okay, I'm getting good accuracy, but this accuracy, is it because it really understood, or it is just remembering, or it is blindly by hearting? That means, okay, I understand it does not have heart, but still if it is blindly by minding, okay, that means if it is 5.4 139, just give 0. Now that is useless, right? Because it can, that means what, if it is by hearting, it will work just for 100, only for the 100 rows. If I give some completely new value, okay, whatever it is not present over here, it will not work. Getting? Because it is getting trained only for this data set. That should not be my goal. My goal is just to train on this data set, but I want to use it on completely different data set. Okay, so now the fundamental problem here is, if you are using the same data set, same set of data for both training and also testing, okay, there is a possibility that the model is not actually learning anything. Okay, it is just by hearting. It is just remembering the input and output and giving the corresponding output. Okay, I mean that it is just remembering all the set of inputs and giving the corresponding output. Okay, so that will be a failure. That should not be our case. Fine. So to avoid that, we are going to pass two different types of data sets during training phase and testing phase, so that out of this 100, let's say we have used some, let's say some 70 rows during training phase, okay, and training the ML model, and this is done. Cool. Now remaining 30 rows are there, right? Those I'm never going to show to the model during training phase. These are kept aside. These are never ever exposed to the model during training phase. Getting? Only once the training is done, everything is good, I am going to take out this 30 rows and then do the testing, the ML model. Now, this ML model which got trained over here, the same ML model, this has never seen this 30 rows till now. Okay, because it is trained only on the 70 rows. During testing only, I'm using this 30 rows. Now, if at all this model is performing on this 30 rows with a good accuracy, let's say 95, then we got excellent model. Getting? Because it is performing on something new, which it has never seen during its training phase. Like it is, just as an example of IIT, you are solving some questions which you have never seen during your preparation. Getting? Here also, it is solving, it is predicting on rows, this 30 rows, which it has never ever seen during its training phase. During training, it has seen some 70 rows, and these 30 are completely different from this 70. Getting, guys? Did you understand this important point?
Yes, Santosh.
Everybody? Any doubts? No? Okay, perfect. Okay. So now we understood 2 points. One is you cannot use the same data, same training data for both training and testing. You cannot do that. Now, what is the other option? My option is you will need to divide the, see, not the training data, actual data. Okay, whatever the data you are having, you cannot use it for both training and testing. You cannot do that. So what is the next option? You need to divide this into training data and testing data. Okay, training data and testing data. Now, training data, obviously the name suggests you will be using for the training, and testing data you will be using for testing. But the important point is never ever never ever mix this test data during the training phase. Okay, this test data should be kept completely separate as long as your model is ready. Okay, because what happens is, see guys, now you have used this. See, now you got 100 rows. Okay, now let's say you are 100. From this, you are divided training into 70 and testing is 30. Always remember, you will have more number of rows in the training and less number of testing, because the more data you have, the better the model you will get. Okay, obviously. So that's why for testing, even we small amount of data is also fine. Okay, because you just want to test whether the model is working fine or not. Okay, just you want to make sure that this data is completely different from the training data. So that's why usually 70, 30, 20, 80. Okay, that means what, 80% training and 20% test data will be considered. Okay, so now you got this 70% of the data. Now using this, take this 70% of the data. Okay, you will be training a model. Okay, now what, first let's say I use some ML model 1. Some, that means logistic regression I've used. Okay, it is working well. Okay, and on this training data only I am using decision tree or some other boosting algorithm, lot of algorithms exploration I'm doing. Okay, and finally some random ML, some, let's say ML10, there is some ML model 10 which is working fine. Okay, this is my model now. But the important point here is, if all this is happening only on the 70 rows, what is this? That is my training data. That is important. Till you finalize on the model, you are not going to bring out this 30. You will hide this. Okay, take this training data, do everything, whatever you want to do, explore the different models, do that. Okay, or you want to optimize, do that. You want to do some hyper parameter optimization, do that. Do everything. Okay, so once you have this model ready, then you will use this 30 rows for testing. Till that point, you are never going to use these 30 rows during the training phase. Okay, I hope that's clear. Yes, guys?
So,
Yes.
Once repeat that one, sir.
Uh-huh.
We are applying the techniques only on training data. Am I right, sir? Not for the testing.
Correct.
Algorithm.
Correct. All the techniques in the sense what? You will train the model on the training data and you will test it on the test data. That means what? See, you got from 100. I'll come to you, Karthik, 1 second. So you have this 70, you have this 30. Okay. You will take this ML model 1. Okay. ML model 1. You will use this 70 for training. Okay. You will train it on 70. Okay. And you will test it on this 30. You can use the same train data and test data. Okay. And let's say you are using some other ML model too. Again, you use this 70 model, 70 rows to train. Okay. And for testing this ML model, you can use this 30. But in every model, this 30 will be separate and it will come only during the testing phase. This 70 will be during the training phase, because every model will have training and testing, right? 70 you will train and after that you will test. Again, same ML model 3, you will use same the 70 rows for training and 30 rows for testing. Is this what you're asking?
My question is that, sir, we are applying the algorithms only for training, not for the testing.
Correct.
You, okay, sir.
Karthik, you're asking something?
I got cleared, Santosh. Oh, no.
Okay. Okay. Fine. So now this, now we understood what? We understood we need to divide the data into train and test. Clear? So after that, how you can do that? See, you have sklearn. Okay, I think this is the first time you came across sklearn, right? So as I said, sklearn is the machine learning library, okay, which has almost all the required libraries, modules for models, pre-processing, accuracies, everything. Okay, so first let me show you how does it look like. Okay, so just like how you have NumPy, Pandas, okay, you also have sklearn, guys. Okay, so sklearn, it's called, actually it's called a scikit-learn. Okay, scikit-learn. Okay, but while importing, we import it as sklearn, scikit-learn. Okay, so just to give an brief. Okay, so over here you will find almost everything. Okay, so for the classification, regression, clustering, PCA, dimension direction, model selections, pre-processing, what all requires to develop an end-to-end ML model, right? So that will be available over here. Okay, you just need to, it is available in different modules and libraries. Okay, so over here if you see from this library, okay, so in you are importing this module. Okay, sklearn.model selection import train test split. Okay, so this train trace split is present in this model selection, and that is present in the sklearn. Getting? So for example, if you see from sklearn dot, okay, so when I press tab, see what all I am getting. See, getting? So over here you will have something called as model selection. Yeah, over here. Okay, and inside this model selection also, if I do tab, okay, there are so many. You have test, typing, split, okay, search, validation, etc., etc. Okay, so over here I want what? I want to import train test split. Okay, I'm importing train test split. Getting is, what does this do? What does this do? That is an important point. Okay, so train test split will divide the data into training data and test data. Whatever we have done just now, it is going to do the same. Okay, so over here, yes, so shall we take a break and continue, guys, or is it fine?
Yeah, how much time it takes?
Um, you're okay, fine. So we'll pause it over here. Okay, so we will continue it tomorrow. Okay, but yeah, it will take some time, Karthik. It's fine. So till now we have just seen till the train test split, right? So tomorrow we will see how to divide the data into training data and test data. Okay, and then how you will use this training data for the model, okay, development. And once a model is once generated, how you can use this test data for testing, and how you can get some accuracies. Okay, and then how you can build the deploy the model. I would say how you can pickle the model. Okay, so there are a few steps involved. Okay, fine, we'll try to take it up tomorrow, or if possible, let me know, guys, if possible we can take it today evening also. Okay, so that we can complete this end to end for the toy data set. Okay, fine. Okay, that's all from because I don't want to start this because this will take some time because I need to explain how does this do, because this is very important step, train test split, how it is divide. Okay, because most of the people get confused over here how it is dividing. Okay, but so let's not do it in a hurry. Okay, so we'll try to understand it in a decent way. After that, there are not many steps involved. Okay, fine. Let's see if we can connect today evening. Okay, thanks guys, that's all for today.
Thanks, Santosh.